Right now, at this exact moment, somewhere in our galaxy, a star just died. Not a peaceful death. A violent, catastrophic explosion releasing more energy in a few seconds than our sun will produce in its entire 10 billion year lifetime. And here's the crazy part. Every atom in your body, the calcium in your bones, the iron in your blood, the oxygen you're breathing right now, was forged inside a dying star billions of years ago. By the end of this video, you'll understand exactly how stars die, why some explode while others collapse into black holes, and why stellar death is literally the most important process in the entire universe. Let's dive in. First, we need to understand what keeps a star alive. Every star is fighting a constant battle. Gravity is crushing inward, trying to collapse the star into a tiny point. But nuclear fusion in the core pushes outward with tremendous force. As long as fusion continues, the star stays balanced. But fusion requires fuel, and when that fuel runs out, gravity wins. The clock starts ticking toward death. For our sun, fusion has been happening for about 4.5 billion years. Every second, 600 million tons of hydrogen convert to helium in the core. That's the weight of 400,000 Empire State Buildings. Every single second. But here's what most people don't realize. The way a star dies depends entirely on its mass. We're not talking about a single death process. There are three completely different endings. Small stars, less than about half the mass of our sun, die the slowest death imaginable. They burn through their hydrogen over trillions of years. The universe isn't even old enough yet for one of these stars to have died naturally. Medium-sized stars like our sun have a different fate. When the hydrogen runs out in about 5 billion years, something remarkable happens. The core contracts and heats up, hot enough to start fusing helium into carbon. But here's the wild part. While the core shrinks, the outer layers expand massively. The sun will swell up into a red giant, so large it will swallow Mercury, Venus, and possibly Earth. Our beautiful blue planet, consumed by the dying sun. Eventually, even helium fusion stops. The outer layers drift away into space, creating a stunning planetary nebula. And the core, no longer able to fuse anything, collapses into a white dwarf. A star the size of Earth, but with half the mass of the sun. A single teaspoon of white dwarf material weighs about 15 tons. Imagine trying to lift a teaspoon that weighs as much as 2 elephants. The gravity is so intense that atoms are crushed together in ways that don't exist anywhere else. But this is the gentle death, the peaceful ending. Because massive stars, they go out with the most violent explosion in the universe. We're talking about stars at least 8 times more massive than our sun. These giants burn through their fuel much faster. In just a few million years, they fuse hydrogen to helium, helium to carbon, carbon to neon, neon to oxygen, oxygen to silicon. The core becomes like an onion with different layers of elements. Finally, the core turns to iron. And this is where everything changes. Iron cannot be fused to release energy. In fact, fusing iron requires energy. The core has reached the end of the line. Without fusion pushing outward, gravity suddenly wins. The entire core, about the size of Earth, collapses to a ball just 20 kilometers across in less than 1 second. The speed of this collapse? A quarter the speed of light. Let me put that in perspective. In 1 second, something the size of our entire planet compresses to the size of a city. The density becomes so extreme that protons and electrons are crushed together into neutrons. You're creating a neutron star. But the outer layers don't know the core has collapsed yet. They're still falling inward. When they hit the impossibly hard surface of a neutron star, they bounce. That bounce sends a shock wave traveling outward at tens of thousands of kilometers per second. The shock wave rips the star apart. We call this a supernova. For a few weeks, a single dying star can outshine an entire galaxy of 100 billion stars. One star, brighter than 100 billion. In 2006, astronomers detected a supernova in a galaxy 240 million light-years away. Without a telescope, just sitting in your backyard, You could have seen an explosion that happened when dinosaurs still walked the Earth. The energy released is incomprehensible. In the first 10 seconds of a supernova, the explosion produces more energy than our sun will produce in its entire 10 billion year lifetime. 10 seconds versus 10 billion years. Now here's where it gets really mind-blowing. During those few seconds of explosion, the temperatures and pressures are so extreme that fusion can create elements heavier than iron. Gold, platinum, uranium. These elements can only be made in supernovae. Every gold ring, every platinum circuit in your electronics, every uranium atom in nuclear reactors. All of it was forged in the final violent death throes of massive stars billions of years ago. The universe recycles everything. But for the very most massive stars, something even more extreme happens. If the core is heavy enough, not even neutrons can stop the collapse. Gravity becomes so powerful that nothing can resist it. The core collapses into a black hole, a region of space-time where gravity is so intense that not even light can escape. The star hasn't just died. It's been erased from existence, leaving behind only a gravitational wound in the fabric of reality itself. In 2026, we've detected black holes ranging from just a few times the sun's mass to monsters billions of times heavier. Every single one was born from the death of a star or the merger of stellar remnants. But here's the beautiful paradox. Death creates life. When a supernova explodes, it blasts all those newly created elements into space. That enriched material forms clouds. Those clouds collapse under gravity. New stars form. Those new stars have planets. Planets made from the ashes of dead stars. Planets with the complex chemistry needed for life. Without stellar death, we wouldn't exist. Life requires elements that can only be made when stars die. Our solar system formed 4.5 billion years ago from a cloud enriched by previous supernovae. The calcium in your teeth was created in a red giant. The iron in your blood was forged in a supernova explosion. You are literally made of stardust. Not metaphorically, literally. Every atom in your body, except for hydrogen, came from a dying star. You are the universe experiencing itself. Think about that for a second. Stars lived and died so that you could exist. Billions of years of cosmic evolution, countless stellar deaths, all leading to this moment where you're watching this video. The cycle continues right now. In the Orion Nebula, just 1,500 light years away, we can see stars being born from the remnants of ancient supernovae. We're watching the next generation taking shape. Some of those stars will have planets. Maybe some of those planets will develop life. Life forms made of elements created in stellar deaths, just like us. The pattern repeats across the cosmos. Astronomers estimate that in our Milky Way galaxy alone, a star goes supernova about once every 50 years. That means in your lifetime, several stars in our galaxy will explode. We just might not see them because of dust. The last supernova visible to the naked eye in our galaxy was in 1604. Astronomers are waiting for the next one. It could happen tomorrow. It could happen in 1,000 years. When it does, it'll be spectacular. The star Betelgeuse, one of the brightest stars in our night sky, could go supernova any time in the next 100,000 years. When it does, it'll be as bright as the full moon for several weeks. You'll be able to read by its light at night. Don't worry though. Betelgeuse is 650 light years away, far enough that the explosion won't harm Earth. We get the cosmic light show without the danger. Best seats in the universe. Now let's talk about our sun's death specifically, because this one is personal. In about 5 billion years, the sun will exhaust its hydrogen fuel. The core will contract. The outer layers will expand. As a red giant, the sun will become 200 times larger than it is now. Surface temperatures on Earth will reach thousands of degrees. The oceans will boil away. The atmosphere will be stripped off. Earth will become a scorched, lifeless rock. But actually, life on Earth will end much sooner. In about 1 billion years, the sun's increasing brightness will trigger a runaway greenhouse effect. Earth becomes Venus. Life as we know it ends. 1 billion years sounds like a long time, and it is. Modern humans have only existed for 300,000 years. Civilization for 10,000. 1 billion years is plenty of time for humanity to spread to other stars. If we survive, after the red giant phase, the sun will shed its outer layers, creating a beautiful planetary nebula. The core will collapse into a white dwarf, a stellar ember slowly cooling over trillions of years. Eventually, in the far future, that white dwarf will cool completely. It'll become a black dwarf, a cold, dark, dead star floating through space. The final fate of our sun, a cosmic gravestone. But even that isn't truly the end, because matter itself may eventually decay. Protons might fall apart. Black holes will evaporate through Hawking radiation. In 10 to the 100 years, even black holes die. True heat death. If you found this mind-blowing, smash that like button and subscribe to your Space Wizard for more content that makes the universe feel incredible. Hit the bell so you never miss an upload. Trust me, you don't want to miss what's coming next. The death of stars is not an ending. It's a transformation. Every element, every atom, every piece of matter gets recycled into something new. Death and birth, forever intertwined. That's the real magic of the cosmos. We're all part of the greatest recycling program in existence.